Okay, good. We are live.
Can you all see my screen?
We can. Okay, yes. So let's give me a short intro, and then Anders, you can kick it off. Okay, right. So today.
Should I stop sharing or?
No, totally fine, totally fine.
Okay.
So welcome everyone to our today's Docker Rosenheim Meetup. So this time it's the first time we're doing it on Zoom, but also streaming on YouTube. So in case you're listening to it on YouTube, make sure to jump over to our Meetup page and sign up for our Meetup to get the Zoom link, at least for next time. Yeah, today we have a special guest. So Anders is joining. He's developer advocate at Styra, and he's one of the maintainers of the Open Policy Agent project. We already did a short Meetup, I think 1 year ago, on Open Policy Agents, or at least I did. Was some intro part, and then really focusing on Kubernetes on the sub-project of Gatekeeper and how to do policies with Kubernetes. Today, Anders will talk about a different use case, basically how to use OPA to decouple your policy and your authorization from your application. So really nice and great topic. Yeah, so we will do a Q&A at the end. So if you have any questions, just then unmute and ask your questions, put them into the Zoom chat or also on YouTube. We will monitor both of them. Yeah, and with this, it's your stage, Anders.
Thanks, Nico. It's really good. I'm really happy to be here. Of course, I'd much rather meet you all in person, but this is the second best option. So great to be here. And yeah, today we'll talk about OPA and policy-based access control. Before we do, a few words about me. I'm Anders. I work as a developer advocate at Styra. And Styra is the inventors of OPA and also the main contributor to the project. I have a pretty long background in software development. And like the last 7 or 8 years, I mainly worked around identity systems, user management, OAuth, OpenID Connect, SAML, that kind of jazz. So mainly proving who you are and based on who you are, what you then are allowed to do in various systems. So identity and access control. And for the last 2 years, I've been working in or around the OPA project, but only at Styra since December. And when I'm not coding and when I'm not working with OPA, I enjoy cooking, I enjoy food, good beers, and the football. And I'm also on Twitter and GitHub and so if you'd like to connect there, I'd be more than happy to. Okay, but obviously not here to talk about me today, even though it's an interesting topic that too. But so OPA, what's the challenge here, and what problem are we trying to solve? As Nico said here in his introduction, OPA is kind of a multifaceted tool, so we can use it for Kubernetes admission control. We can use it for application authorization, and there's so many use cases. So the challenge that OPA is trying to tackle is really to manage policy in increasingly distributed, complex, and heterogeneous systems. So the world is complex, and we need some way of working with policy and rules across the application stack, across these kind of platform and application deployment stack, across our cloud environments, and across our databases. So if you go to any kind of zoom into any of these technologies, you're probably going to find that they have their own way of working with rules, working with config, and working with policies in general. Who can access what parts of your Azure cloud, or who can do certain actions on certain endpoints in your microservices. But the problem is that these rules and policies are all going to be written in like entirely different languages, and they're gonna be logging in their entirely own ways. So there's really no unifying factor in this. And that's, of course, the goal of OPA. It's to unify policy enforcement across the whole cloud native stack. And just a stack here, because even if OPA is kind of built from the ground up with cloud native technologies in mind, it's certainly not limited to that. So if you want to run OPA on, I don't know, on the mainframe or something like, or some legacy environment, we see a lot of that as well, and it works really well. So that's kind of what OPA is. It aims to unify policy enforcement across this stack. So a bit more on OPA. It's an open source, of course, general purpose policy engine. And the general purpose here, that's really key. It kind of has to be in order to support all these technologies and all the various things in these stack, and all these, not just technologies, but entirely different platforms and kind of conventions and paradigms. Obviously, there's miles of difference between, I don't know, the AWS cloud and some Java application, but yet we can still use the same policy engine to govern and write policies for both. And that's kind of a testament to the general purpose nature of OPA. What OPA offers is a unified tool set and a framework to work with policy. And of course, we'll look into in a bit here what policy is and what that entails. And the outspoken goal here of OPA and I guess like for most policy engines, what you want to accomplish is that you want to decouple policy from your application logic, or what you normally refer to as business logic. So you kind of take policy and you kind of lift it out of your application, you extract that, and you'd rather delegate that responsibility to OPA. So in your application code, ideally, your Java app or your .NET app or your Clojure app, it doesn't need to know that there's an admin role, that there's a doctor or whatever it might be with regards to permissions, because that part has been delegated over to OPA. And once the request has passed into your application, you should trust that this is allowed, or this should be, the request should proceed from there. So that's kind of decoupling of policy, and with that decoupling, there comes a whole lot of other benefits, which we will look into more this evening. One thing to know, though, or to note, is that what OPA really does is policy decision. OPA works kind of like an oracle. So you ask it questions and you get back answers. But OPA doesn't enforce anything itself. So maybe your application would ask something like, I have this user here, and that user is trying to access this endpoint. Should we allow that or not? And OPA is going to say yes or no, or it's going to say allow or deny, or whatever OPA decides to respond with, based on like preloaded policies and based on knowledge around the world. But OPA itself is not going to really do anything about it. It's just going to tell your application what its decision was. So it's still up to your application, or up to your whatever these other technologies might be, to actually enforce that. And of course, enforcement is normally to send a 401 response, a 403, maybe send some a message to a Slack channel, whatever is appropriate, or like even call the authorities if it's something like super serious. So enforcement could really be anything, and OPA kind of leaves that outside of what OPA does. So as for the policies themselves, they're all written in a declarative language called Rego. And no surprise, we're going to look more into that in a little bit. So again, since OPA is general purpose, some of the most popular use cases, and there's a lot of them, ranging from Kubernetes admission control, which I think you've kind of touched on before. Microservice authorization, I think, is the big one. It's certainly, I think, the big one for Styra and for like these kind of large multinational companies, because it's a hard problem to solve. Like Kubernetes admission control is important, but I'd say it's kind of a solved problem. It's not as advanced or complex as many try to frame it as. Microservice authorization, on the other hand, is kind of complex, because all organizations have their own rules, and they all have their own like permission data sources and their own like legacy systems that you need to interact with. So it's a much more complex but I also say a lot more interesting domain. And that's what we're going to be looking at somewhat today. Of course, we only have time to do an introduction. But of course, if you are all interested, we can certainly do like a deep dive session at a later point too. Another, I'd say, emerging use case and more increasingly common is infrastructure. So you have policies governing Terraform and other like infrastructure as code tools to say that you may not deploy this or that many machine or instances of virtual machines or whatever it could be, because maybe it's just going to be prohibitively expensive, or it could be that you can't deploy this machine type on the public network, because then you'd kind of breach data, because that has access to some internal. So any type of policy around infrastructure, and this is also becoming more and more common. Maybe not so common yet, but I'm hoping it will be, is using OPA to kind of filter data from data sources, such as Elasticsearch, MongoDB, and whatnot. There's CD and CD or CI and CD, like build and deployment system pipeline policies. That's pretty popular, pretty common. So you can pretty much say that we don't allow deployments after 5 o'clock on a Friday night, because people are probably wasted by then, and it's not going to be a good idea to have all developers handed the key to the deployment pipeline, something like that. So that was a basic introduction to OPA. Of course, OPA is not just a project, but it's a whole vibrant community, and we have I'm just not gonna read all these numbers, but just know it's a very active, vibrant open source community, and there's a whole bunch of integrations and kind of projects around in this OPA ecosystem. We have conf test for testing config, gatekeepers for doing this Kubernetes admission control. There are various editor integrations and so on. Of course, it's not just, OPA isn't just like some hobbyist open source project, but it's actually used by, I would say some, but I'm gonna even stretch that a bit and say almost all big companies in the world have some, even if it's just like a small like proof of concept, or at least most of the big ones are using OPA to some extent. And I think this is a quote I think kind of sums up what OPA is really about, and this kind of unifying factor for policy. So the Open Policy Agent project is super dope. I finally have a framework that helped me translate written security policies into executable code for every layer of the stack. And that pretty much sums up what OPA is about. So Rego, then, we kind of touched on the policy language for OPA. But before we proceed into Rego, let's first see how can OPA be, how can we do this kind of general purpose? How do we solve that? How do we integrate with all these services and applications and languages? And the way it's really done is this policy decision model and the simplicity that it allows. So the way it works here is really that a request comes in to our service. And when we say service, we don't necessarily mean like microservice. We just mean any type of service. So this could be a microservice. It could be the Kubernetes API. It could be Kafka. It could be a Linux PAM module. There's really anything that accepts a request. And of course, that's pretty much the definition of a service, that it services requests. So a service receives a request, and before it kind of services that, proceeds, it sends a policy query to OPA. And this policy query is just an HTTP request containing any JSON value. And OPA, which is pre-populated with a policy and possibly data about the world around it, can then respond with a JSON value, which is the policy decision. So any service which can send and receive JSON over HTTP can integrate with OPA. And that's of course why OPA is kind of so prevalent in the cloud native space, because pretty much any service can do this. That's been, at least that has been written in like the last 10, 15 years or so. So how do we deploy OPA? Like, how do we actually run it? OPA is a self-contained tiny little binary. And ideally, you'd want OPA as close to your service as possible, because since there is still this little network hop, you'd want to minimize the delay or the latency between OPA and your service. So the way you normally deploy OPA is actually on the same machine or the same host as your application or as your service. So either as a daemon, or in the Kubernetes case, you'd run it as a sidecar container. So it's always on local hosts, or that's at least the ideal. And then you'd have your applications talk to OPA over this REST API. And there's also some more kind of esoteric ways of communicating with OPA. If you have a Go program or application, you can actually, since OPA is also written in Go, you can talk to OPA directly as a library. And if you're using Envoy, Istio, there's a plugin for OPA, so that Envoy and Istio can talk to OPA as well. And finally, there's also the option to compile your OPA policies as WebAssembly modules. And by doing that, you can obviously, then you can run OPA inside of environments where you might not have these kind of HTTP or access to REST services or REST clients. Or if you just think like this, like 1 or 2 milliseconds of latency is too much, it might also be a good option. Okay, so we're getting closer and closer to the really fun stuff here. So let's carry on. Policy offering and Rego. And Rego is this declarative high-level language, in which we write policies for OPA. And when we say declarative, we mean kind of like SQL, that you don't really say how you need something done, like a for loop or so, but you'd rather say what you want. So that's kind of what a declarative language is, and it's high level. You don't need to fiddle with like the details, but of course it is kind of a different way of thinking about rules and policies. So it does take some time to get used to and learn. What a policy is really a number of rules. That's kind of the most basic thing to note about Rego. And these rules, again, where OPA works with JSON, so a rule can return any value that is valid JSON. So this could be a Boolean, but it might as well just be a string, a list, an object, anything that is valid JSON. There's it says 140 here, but I think it's over 150 now built-in functions, which are included with OPA. Anything from dealing with like JSON web tokens to date and time to IP addresses and so on. And OPA ships with a unit test framework, so it's easy to test policies in isolation. And that's another benefit of kind of decoupling policy from your application logic, that you can also test policy in isolation. And obviously then you can also share policies between different services and know and have that kind of confidence that these policies have been thoroughly tested. It's a well-documented project. Check out the OPA docs. And of course, the Rego playground, I think that's one of the better playgrounds I've had the opportunity to work with. Before we actually look at the Rego playground, I want to just mention here, we talked a lot about policy. If you remember from that policy decision model, there's also this little data icon. And of course, policies are great, but they normally need data as well, because we need some information about the world. We might say that nobody from outside the organization has access to these systems. But that might be our policy. But that policy isn't very useful unless we know who is part of the organization. So that's what we call policy data. And that type of data can be sourced through various ways. It can either be as part of the query, you can either push data into OPA, or you can have OPA pull data in form of what we call bundles. And as a last option, we can also actually reach out and use the HTTP client at policy evaluation time. So from inside of our policies. And that's it for policy and data. And I know it's been a lot of information to digest so far, a lot of slides and bullet points. So I'm thinking this would be a good time to hop over to some policy offering. And what you see in front of you here is actually the Rego playground. And this is an excellent resource if you just want to try out like working with Rego, working with policies. You'll find a lot of examples here if you want to like have something to start from. Maybe you want to work with like RBAC, ABAC. Maybe you want to see like Kubernetes admission control, anything like that. So this is a great resource to use to get started, but also to kind of experiment with Rego. What I'm going to do here now is, to your right here, you can see the input. And what I'm trying to do here, I'm trying to simulate how the microservice or an application really would query OPA. It would probably say something like this. It would say that there's an incoming request here. The path of this request is to the user's endpoint. And of course, I've made this into an array, but it could also be, it could also look something like this. And that's probably more likely, but since arrays are generally nicer to work with, I'm just going to assume here that the client split up the input or the path on slash. So the path would look something like this if this was a request to see the Anders user. Okay, enough about that. So we can see here we have an incoming request, a GET request targeting the user's path. So now if we want to allow that, or we want to work with a policy for that, we write our first rule. And the way rules work in Rego is that they have a name. In this case, we might want to call this allow, but allow has no meaning in Rego. So allow doesn't mean anything. Deny doesn't mean anything. Violation, or these names have only meaning to us as humans. They're not keywords or anything in Rego. You can name them whatever you want. If you'd rather work with like yes or no or whatever. But I think allow and deny, those are pretty common conventions. So the way a rule works in Rego is that you have the rule here, the name of the rule, and it's followed by a body. And if all the conditions inside of the rule are true, then we say that the rule is true. So if we do something like this, 1 equals 1, well, that's true. And we add another condition here. We say 2 equals 2, that's true. And if we evaluate this rule, we're going to see that this is true because both of these rules or both of these conditions are true. So the way you can think of it, if it makes it any easier, is you could say something like this. If you come from any other programming languages, this is how you write it. In Rego, this is just implicit. So each of these conditions, they're ANDed together. So if we add any conditions which is not true, we see that allow is no longer true. In fact, allow is no longer nothing. It's just undefined, and that's just how Rego works. If something doesn't evaluate, it doesn't evaluate at all. It just does not exist. So if we still want some answer, we could just say that by default, the allow rule should be equal to false. And now we can see that no matter what we have here, allow is still something. It always gives us something back. Now, of course, this is kind of a silly example. We're not really interested in these, just comparing these constants. What we want to do here is we want to use the input here up to a right and write some policies around that. So what we might want to say, for example, we can say that the input path, and I'm just going to say like the first index of the input path, because of course there could be any number of path components following. But if the first path component is equal to path or users, sorry, and the input method is equal to get, then again, remember, if both of these conditions are true, then allow is going to be true. So if we do something here, we change this, I don't know, put, and we evaluate, we see allow is not true. So the app is going to ask, can we modify the user's endpoint? OPA is going to say no, allow is false, because you can't do that. Our policy permits that. And can we get the user's endpoint? Yeah, we can. So in this case, it's not really, this is probably not really like authorization. There's no user involved. The only thing our policy says so far is anyone can read from the user's endpoint. We can send a GET request. If there's any other endpoint, or if there's any other method, we're going to fall back to the default value of allow. So it's going to be false. So essentially what we're saying here is there's only one allowed operation on one single endpoint. So what if we want to add more now? We said before that conditions here, you're going to AND it together. So you say AND. What if we want to say OR? The way we do that is we create a new rule, and we can also name that allow. So this means that we add a new condition for which allow can be true. So if we say something like the input path, and now we're actually going to compare, or we can still do there. So if the first path component is equal to user, and we're going to say if the next path component is equal to the input user name. Of course, we don't have that yet, so we're going to add that. User, say name, Anders. So again, this is all, this would all come from the query from the application. And of course, what data the application provides, that's going to have to be like up to you to decide, and the contract between the application and OPA. And we might want to send email or something here as well to make it look nicer. Okay, so now we have an application. It not only does it provide the path and the method, it also provides who is trying to do this. So if we say here that the next path component, Anders here, if this path component is equal to the input user name, so Anders, both of these are equal, right? And the input method is equal to put. Then, like if all these conditions are true, then allow is going to be true. So we can see here, if we change this to put now, we should still be allowed to do this. Yes, and we still are. So the meaning of this is, of course, that anyone can edit users, but only if the user is equal to the actual user sending the request. So you can edit your own user. You cannot edit, I don't know, if we try and change the username here, if I try and edit, I don't know, Jane, we see that I'm no longer allowed to do that. So this is, of course, very basic policy offering, but just on these 14 lines of Rego, you can cover the basics of how Rego works, how rules work, how you can how you can build these kind of multiple rules to build and add new conditions for your rules, and how you can work with input data and so on. And then of course there's a lot of things we don't cover here. We don't cover any of these kind of built-in functions because we haven't really needed them. We don't cover iteration. We don't cover so obviously this is a short example, but I hope it gets the message across that in just quite a few lines of code, we can express quite powerful policies. Okay, are there any questions now, or should we wait with them until later?
So far, we don't have questions yet, neither on YouTube or on Zoom.
Okay, great. I'll just carry on here then. So I know you covered the Kubernetes use case previously, but I'm gonna give you a little reminder here anyway. So the way OPA works in this context, it kind of hooks into the Kubernetes API servers, and the way any requests kind of is trailed down in the Kubernetes API is through these series of modules: the authentication module, the authorization module, the admission controller, or the mutating and the validating admission controller. So, and these modules are all chainable. And there's a whole bunch of built-in modules, but what we really care for here is, of course, the webhooks. Those allow us to use OPA. Again, what was OPA? What's the interface of OPA? It's a REST API talking JSON, and that's exactly what these webhooks are. So if we want to zoom into one of these the validating one. I think that's by far the most popular module to extend. What it allows us to do is really to build guardrails around Kubernetes clusters. So we can say that, for example, we don't want to allow any deployments where the Docker registry is not the internal company registry. We don't want to allow any deployments or services or anything without the required labels. So maybe the team name, the cost center, so on and so forth. We might want to enforce TLS communication. We might want to deny certain attributes. We might want to put limits on resource allocation and so on and so forth. This is really what validating admission control is about. It's about enforcing certain limits on our cluster and rules and policies. And again, the way we wrote policies before that I just demonstrated, it's going to be pretty much exactly the same that you write these type of policies. And that's the whole idea behind OPA. Again, this unified way of dealing with it. So if you learn, even if you might think there's a steep learning curve to OPA and Rego, then it kind of pays off eventually, because then that knowledge that you acquire learning Rego for admission control is directly transferable to writing policies for infrastructure or writing policies for microservice authorization. So the way it might look here, just to give you all a simplified example, is the input. That was what we had to our top right before. It could look something like this. Just have a JSON object. In this case, it's a pod somebody's trying to deploy. In the middle, we have a policy. And in this case, we named it deny. And we also add a message to the deny so that the user knows why the request was denied. And in this case, we say that every resource must have a cost center label. And if you check the labels on this resource, it doesn't have any labels at all. So, the end result is going to be that the request is denied, and the user who said kubectl apply, he's going to be told that this request was denied because you don't have a cost center label. So they'll get a chance to redeem themselves and add the appropriate label. Finally, and leaving the Kubernetes world, because this is something that benefits OPA in any deployment type, whether you do it for services, Kubernetes, or infrastructure. OPA has a number of management APIs that allows you to really run OPA at scale. And this is obviously not where you'd start your OPA journey, but it allows you to scale OPA in really large organizations. There's the bundle API, where you can kind of package your policy and data into bundles and then distribute them to OPAs. And this could be hundreds of OPAs or thousands of OPAs. So all OPAs can have like a phone home option to go and fetch policy and data every 13 seconds or every minute or whatever interval is appropriate. And this allows for some super cool deployment options where you have distributed enforcement, but centralized kind of policy offering and policy management, which I think is pretty much necessary in larger organizations. You need to know what's going on. And the decision log is another kind of step in that direction. Means that all these OPAs distributed all over your cluster, they also can phone home to say or report back on all the decisions they ever took. So this allows you to know what's going on in your clusters. Where do we have violations? So you can do this kind of auditing, and also, of course, you can use this to actually work and refine your policies. So you might not be that there's actually some criminal intent. It could just be that you actually missed some conditions when you wrote your policies, and you have to fix that. There's also a status API for just reporting like health, not as interesting, and a discovery API to have also like the OPA configuration periodically fetched from a remote endpoint. So if you think this sounds interesting and it's something that you'd like to explore, here's some tips I have for getting started. The first one I'd say is just start small, like maybe try and write a few little simple policies using the playground or using your an editor plugin. Make sure to browse the OPA docs. Again, I think they're a fantastic resource. So don't miss on that. And once you kind of have the basics, then you can start to consider applications close to you. Like maybe have a look at some apps or some service you've worked with previously, and then try and identify where do we have policies today. I guess it's normally going to be around authorization, but it could be in any other domain as well. And once you identified some policy you already have, then you can start to delegate that responsibility to OPA. And again, you don't really need to like rewrite your whole application from day one, but maybe you can start with just a single endpoint or maybe a single role, like the admin role. So you start to delegate that to OPA, and then you start to build your experience and your kind of what you know, and build confidence in OPA from there. And after that, then you can scale up. Then you can start to look into these kind of policy management. How do we do this at scale? How do I make a policy change and have that deployed to hundreds of microservices without having them all redeploy, for example? Logging and so on. Also, if you're keen on learning, check out the Styra Academy. It's an online resource, kind of video based, and also it has these kind of quiz style tests after. The Styra DAS, which is the Styra commercial component, it's a commercial control plane. We also have a free edition, so if you want to try that out for policy offering, policy distribution, and so on, you're free to do so. And of course, it's the OPA Slack community. We have 4,000 or so members, and it's a vibrant community. So it's a great way to ask questions and see what others are asking and what others are working on or struggling with, and so on. And with that, say thank you. That was my introduction to OPA. And if there's any questions, I'd be happy to answer them.
Cool, thank you, Hannes. So on YouTube, we do not have any questions in the Zoom chat we have. So I'm not sure, you can either, if you have any further questions, just verbalize or unmute and verbalize them, or we, starting with the questions in the chat. Okay, so first one, in Kubernetes, why should I go with Rego? When can I use Kubernetes and a more Kubernetes native approach? So basically the difference between Kubernetes and OPA gatekeeper.
Yeah, I think the key there is first of all, I don't really know if I agree that Kubernetes is more Kubernetes native. They use these kind of custom resource definitions, and they basically use YAML to encode policy. And right, and if you think that sounds like a good idea, then of course you can go ahead and use that. But I think if there was one message that I really wanted to kind of get across today, it is, again, this OPA is not about Kubernetes admission control. It's just one of many possible applications. So I think this kind of this idea of using one single policy language across the whole cloud native stack, that's the basic idea of OPA. That's the basic idea of Rego. So using Kubernetes for admission control is probably great for just that single domain. but it still means you still have that problem that we try to tackle it from the start, which is to have one way of working with policies across the cloud native stack. And Kubernetes doesn't solve that problem.
Okay, thanks. So we have another one. Is there any converter between extended access control markup language and Rego?
Oh, that's a good one. No, I don't think I've seen a converter. I'd be very interested to know if there was one. So for anyone else not familiar with XACML, it's basically yeah, when was it? When is it from? Like 2001 or something. So it's basically 20-year-old standard for working with policies, and it's an XML based standard. So it has certainly aged, and yeah, depending on who you asked, might not have aged too well. But it's 20 years later, so it's kind of hard to blame whoever wrote the first XACML spec like 20 years ago. But I'm not familiar with any like automatic converter, but I'd love to know if there was one.
Okay, so we have a few more. Can policy decisions be based on previous decisions? So for example, a client is not allowed to download more than 5 documents a day.
Yeah, that's a great question, and the answer is yes. That is possible, but OPA itself you can have these kind of data provided to OPA, either put in OPA's memory or as part of your query. OPA really isn't meant to kind of keep state between requests. So if you want to do something like that, like a counter or something that increments with each request, you're better off doing that outside of OPA, and then just provide that number to OPA with the request or something like that. So the application would say like, this is the 5th time I got this request, and then you'd have a policy inside of OPA which is said like the max number of requests is 5. But having OPA keep that track of that number is not a good idea.
Okay, so have you seen any common security misconfiguration traps when people start out with OPA? So bypassing policies, missing edge cases and stuff like this.
Oh yeah, that's a great question. Yeah, and I think there's certainly like some kind of common rookie mistakes, and I think we have some job to do in kind of making those harder to do. I think a pretty common mistake is when you write these kind of deny style policies where you say like, if this and that happens, then I want to deny the request. Because obviously if you write policies in that style, then it's implied that any other condition is going to be allowed. So while you can certainly do that, I think that kind of way of thinking is way more complex than people realize. And also with OPA's way of dealing with undefined values, it can make things rather tricky. So even if you say like, if the input role is equal to admin, then, or is not equal to admin, then I want to deny the request. And then if there's no role at all in the input, OPA is just going to say, yeah, that's fine, because undefined was not like, that just stopped evaluation. So yeah, there's certainly a few like kind of quirks, but I think the unit test framework and things like that certainly helps to catch things like that early on. So I think that like testing is certainly, if not a requirement, then certainly a best practice.
Okay, 2 more. Do you have any recommendations for OPA scale out? So basically, syncing the different instances for the bundle API, REST API, push model, and so on?
Yeah, I think the easy way of doing it, if you can do it, is to have OPA like pull from remote endpoints, the bundle API, rather than like pushing data into OPA. The current drawback of using the bundle API is that if there is a change to policy and data, OPA is going to go and fetch all of the data again. So if you're dealing with like a huge amount of data, then the policy API, or sorry, the bundle API might not be for you, and then you'd rather kind of need to push these deltas into OPA. But I say always start with the bundle API and start with decision logging to just kind of know what's going on. And by all means, try out the Styra DAS, the free edition, even if you don't want to use it or go with a commercial option. It could still be useful to give you some ideas in how that could be done, and it could be useful if you want to implement something like that yourself.
Okay, last question is, it's not the last question, we got another one. Will OPA also support Zanzibar? To be honest, I don't know Zanzibar. I'm not sure if you do, Anders.
Yeah, I've a basic understanding on
okay.
So Zanzibar is originated out of Google when they wrote their authorization stack. I think this was from the years of Google Plus, when all these users was meant to interact with each other. You were meant to be part of these bubbles, and so they had quite an advanced model of authorization, and yeah, of course, as it really scales well. I think it basically is a more centralized model than OPA, but of course, if you have like Google resources, I think you can make most things scale pretty well. So, and I think it's a fairly good model. It seems pretty advanced, but I don't think for like the general application use case, most organizations have no need of like that kind of Google scale. But yeah, I know there's a few projects now to try and kind of do this more for like an open source implementations and so, because that's the Google implementation is not open source. It's just a white paper pretty much. So there's a few projects now that are trying to do this. I know there's one trying to do this as an open source project, the Oriketa or something like that. And there's also a couple of companies trying to create like their commercial applications of this. So yeah, it's definitely something to look out for, or to be kind of to inform yourself about. And I think it's only, and again, just as with Kyverno, it's probably good at what it's doing, but it's also only meant for authorization. So it's not meant to solve kind of infrastructure policies or Kubernetes admission control. So even if all these kind of competing technologies have their own kind of domain and they solve that problem really well, it's not really the point of OPA, but to kind of do this general purpose policy engine thing, there's really not a whole lot of competition in that space.
Okay, and maybe now the last one, any suggestion on how to roll out OPA in an enterprise environment where different domains owned by different departments?
Wow, yeah, that's a complex question, and yeah, of course, I've actually before I started working for Styra, so the last 2 years before that, I actually did this kind of rollout in a big company spanning 13 different countries with 50 different dev teams. So I've definitely done this, but I don't think I can just cook it down to like a 10-second recommendation on how to do it. But I'd be happy to talk about that later. But yeah, I think if I just should say like something, I guess like a key to doing this and having a successful outcome is probably like how you choose to centralize some policy decisions and how you work with. So you can either say like all teams, they can write their own policies and they can just kind of take OPA and do whatever they want. But I think eventually in these kind of larger organizations, you're going to want some form of centralized governance, and then you can have your teams add like their freedom on top of that. But you still have like, these are the basic rules. All services must adhere to these rules, and then you can add your own stuff on top of that. I think that's a good model.
Okay, so does anyone have any further questions to Anders? Let me check again the chat on YouTube just to make sure we do not miss any questions. Okay, no, this one looks good. Okay, so I think we are done. Thank you, Anders, for the great talk, the awesome demo, all the details. So we have a question. Which question did you wish we ask? Any questions? Okay. Yeah, so thanks everybody for joining. Thanks, Anders, for the great talk. And yeah, have a great evening.
Thanks, everyone.
Thank you, Anders.
Really appreciate it.
Goodbye.
Okay.
Goodbye.
Bye.